Welcome viewers, this is part 6 design of warehouse structures. In this we are going to do the connection designs for various connections which is required for the warehouse building. So in this we are going to cover pinned main column connections, pinned window post connections, pinned door column connections. So these are the connections which is having connections between the foundation slabs or foundations to the structure column. And the fourth one is a column to rafter connections which we are going to do. You can see on the right hand side pictures. The first one is a column to rafter connections where it is having a bracket at the bottom in yellow color. So similar like rafter to rafter connections, ridge connection also we are going to look. So this is also having a bracket. And finally we are going to do the wall bracing connections and the roof connections. Let's look into that model.
The connection design, we need to have this kind of Excel format so that it is easy for us to extract the robot structural forces and placed over here, and we can get the exact value which is to be applied on the connection of the robot structural analysis. So now we will look into that model. So from this model we need to do the connections, the following connections. One is pinned main column base connections for the anchor bolt and the base plate, and similar to that wind post also we need to do for this. And next one is for door column we are going to do the base plate and anchor bolt design. And for column to rafter connections, next one is beam to beam splice connections are the apex connections we need to do at the ridge, wall X bracing, and finally the roof bracings which we are going to do the connection design in robot structural. So coming to the model, go to design, click this steel connection design. There are some by default other commands are there, other connections are there, you can forget about that. So first we need to do that main column base plate and anchor bolt design. So as you know that our standard model we have done pinned connections at the portal frame base. So go to this right hand side pinned column base, click that icon. So here we can add it as pinned column base or by default anything, and you can change the number to 1 because this is the first connections we are going to do, and this IPP we need to change to that exact number which we are having. So as per our structure model, we have assigned 533 by 210 by 92 as a main column member, and we are going to assign this grade as S355, and this is without a bracket. You can click apply. Go to the plate. In the plate we need to make the anchor bolt sizes, and according to the anchor bolt spacing we need to assume some values for the initial stage. So later after checking if the design is failing we can increase that, and go to anchorage. In that anchorage we need to select the type of bolt and the anchor bolt arrangement in the column base. So we can assign this 4 number of bolts inside the column web, inside the flange distance of the column, and we can type the vertical spacing, that is here you can see this in the picture. EH and EV are there. EV are the mentioned as a vertical spacing. So vertical spacing we can add it as 350 by 350 as a horizontal spacing also. And this anchor type we can select the anchor plate with the square plate at the bottom. You can see the picture here like this. So we need to define this also, and we can assign this as a M20 bolt with a grade of 8.8, and we need this the projected length after this base plate is 130. We can assume this, and L2 is a anchor bolt inside the concrete embedded one, we can assume as a 300, and 50 mm is a anchor bolt from the connected plate at the base of the anchor bolt. So this L3 dimensions we are typing here, and anchor plate size also we can define as 100 by 100 by, so this we can define as default, and the plate thickness if required we can type as 15 mm thick. So this is what we need to assign all the grade S355, and click apply and go to wedge. We don't have any wedge. Wedge is some small projection below the base plate, so we don't have it. We no need to consider at this stage. Go to weld. So weld, in that we need to define the thickness. So thickness generally we used to define as per the thickness of the base plate or the connected member web. So in that we need to consider 2/3 of the thickness of the base plate. So for 20 mm, if we are considering 2/3, it will go some 13 mm, but 13 mm is a huge one. So for this we can just check this with the 8 mm, and let me see if it is fast in 8 mm, then we can limit with the 8 mm and click to the foundation. So this foundation depth we need to assign, so we can assume as 800 by 800 by 600 as a plan size and the height of that, and we can consider the concrete strength as C32 or 40, and thickness of grout we can assume as 25 mm. Click apply, and next go to the code parameters. So these are all okay by default. We can consider sway conditions and the cracked concrete. So grouting layer, so that the grouting layer also don't going to impact on us. So we need to tick this CEB analysis also, and tick all this and click OK. So here that number is not yet changed, so we need to change this number also, so that it can be added in the first. Now we need to apply the forces. So for this force value we need to go to the structure. You can save this, go to the structure view, select all the column, and go to reactions. So these are all the various reactions at the various load combinations. So we need to consider that node number 1 to 14 for main column. So as you can see, these are the node members for the main column 1 to 14. So in that, go to this tab global extremes. So here we need to type it 1 to 14, so that the value you can directly copy and paste to the Excel sheet which we are having. So we can able to get the force values which is required for applying to the robot model. Then go to that connection design. So here we need to apply the force value as per the Excel input. So 35 is a FX value. So after entering all the values, so here this FZ value should be entered as a minus because it is a downward forces, and click calculations. So you can see that the usage ratio is 0.93, so hence this connection is safe. So similar way we need to apply for the wind post also. So for that you can also create the new one. So we extracted the win post pinned main column values from robot. So this is a summary for that. So we are going to apply into that model. So after entering all the values, you can click calculate, but here it is a failing. So either we need to check where the fail is happening. So it is a concrete edge failure. The failure behind this wedge is need to be modified. So for that, click this, double click this connection option. So go to this code parameters. So this CEB analysis and design of guide. This guide is not applicable because this is not subjected to the building model where which we are having a pinned support. So unselect this and click apply and OK, and run this calculation again. Now this connection is passed with a usage factor of 0.62. We need to also modify this pinned column base which we have selected as a CEB analysis. So now you can see that the usage is less than that earlier. So if we want to do some optimization, we can also reduce the base plate thickness or anchor bolt, whichever is having very less utilizations. So next we need to go for another connection, that is connection base plate and anchor bolt for door. So for that also we need to go the similar way which we have done for main column and the wind post. Click here pinned post. So we extracted the value of normal force, shear force from the robot structure model and posted in the Excel, and now again we are applied this into this tab and clicking calculations. So we can see that it is usage factor for the door, base plate and anchor bolt is 0.56 only. So this is also safe. So whenever we are doing this input, giving the connection input, now we can able to see the scheme of the connection also. So wherever these dimensions we can see here, and if it is required we can correct in the main this tab also. And this connection view also we can see in a 3D view. So this is a general, we can able to adjust according to our this view. Next we are going to do the connection between the main column and the rafter. Go to the right hand side tab and click this frame to knee connection. So this tab, in this tab we need to select the, we need to enter whatever record like column rafter connection, and this is bolded, and we need to feed the sizes of the column and the beams. Next we need to select the grade of steel and the angle. As you know that in our model we have our angle of rafter is 5 degree. So you can apply here, and you can also see the view of this. And next go to the plate. So in that plate we need to define the size preliminary. I am going to enter here some assumed value, and EPU is at 10 mm and 50 mm. So you can see the picture and enter the value as required. So this will by default change according to the size of the column also, even though if we are defining that. And go to brackets. So we don't need any bracket at the upper side of the column. We need only at the bottom side. So that we have selected here lower. Even there are some other cases also for in the lower. If you want to select with the same member, you can select here, and the height we can define as the same depth of the Rafter 533, and the length we can consider 1200 mm, which is a 10% of height of the column. So the width we can assume some 210 and 21 flange dimensions, and we can assume the gray as S355. So you can see the view here, and there is no upper stiffener plating and the lower stiffener plating. Go to the bolts we need to define. So bolt we can assume as 20 mm dia and with a grade of 8.8. So this is unthreaded portion only. The shear plane is going to occur on unthreaded portion, and this number of poles we can assume as equally as 6. So you can see on the picture that 6 number of poles are there, and the horizontal spacing you can consider as 120 because it is exactly falling on the flange, and we need to enter the spacing between that 180 comma 180 comma 180. We are having an equal spacing. So totally 6 number of poles rows we are having. In that we need to apply the 5 spacings. So you can see here no bolts are clashing with the structural members. So next to go to the stiffeners. So for the stiffeners we need to define the grade and the thickness of the plate. So here we don't need any horizontal stiffness, we need only the vertical stiffness. So click the vertical stiffness. So that thickness we can have it as 20 mm because this 12 meter column we need to have some big stiffness. Go to weld. So in the weld we can type whatever the weld thickness which you are required. So all weld we can consider as 8 mm thick, and go to the code parameters. So these are all okay. Click OK. So in order to apply the forces, we need to extract the force value from the robot structural model for columns and the rafters. So this we need to go to the robot model, the structure model, and select the column. So column we can select from 1 to 14, which is a main column, which are applicable to connect with the rafter. And we need to take the force value here. So go to the results, forces. So again here also we need to take only the global extreme values. So once after this force value table is arrived, then we need to type here 1 to 14, and here we can no need to select the load cases, so that because we are going to take the global extremes only. So this part we need to copy and paste into our Excel sheet. So similarly we need to select the rafter also. So rafter we need to select from the main window, or if you are assigned the number you can directly select that. So it is better to make a grouping system. So for column we have assigned already a different group, and for the roof rafter beams, so we have assigned this group, so that from this we can able to get the force value. It is a 18, so you can directly select the group, so that this force table also get updated. So we need to copy paste and into that Excel file which we are already having here. So then we can able to get this value which are formulated from the robot structural input. Now go to the connection design, which we have already defined the column and rafter connections. So here we have already defined the sizes. Only thing we need to feed the forces here. So click these forces in member and enter all the values in Excel. So all the values as per Excel are entered here. So you can see here that internal force in the beam right side is given, so that we are designing the right side of the beam. Actually this table is meant for the column with two beams, but our case is the left side there is no beam, because we are going to connect only one rafter in the one single column. And coming to the internal force of the column, the bottom, we are not going to apply the bottom the rafter, so this is not applicable. Only in the top force we are going to apply, because at the top only the rafter is connected. So applying all the value, click this calculations and it is calculated, and the usage ratio is 0.6, which is less than the 1, and we are in safe. So this connection is safe. So next we need to do the rafter to rafter connection, that is apex connections. For a rafter connection, we need to click this beam to beam connection. So here we can define the connection ID as a 5, and we can also type here the name. So I have typed the name as rafter rich connection, and this is a bolted connections, and we need to assign the member sizes as per the structural model, and the grade of steel. So we are having -5 degree. Apply here, and in the other side also we need to apply that 180 degree minus 5 degree, it will be 175 degree. So this is also a minus, which means it is in downward. So you can see the image of this. So our rafter will be like this, and this connection bold part we need to update again. So next click this plate. So for the plate we need to assume some value initially. So we can assume some bigger value, 250 and 20 mm thickness of the plate, and this 10 and 13, these are the gaps between the plate and the column. And go to brackets. So this brackets, we are not going to do any bracket at the upper vertical bracket, there is no upper side, only at the bottom side we are going to provide some haunches or additional member. So this way we can do it, instead of doing the rectangular, this is a more common, the triangular shape. And here we are going to have a height of 460 and 980 mm. So 210 we can consider, we can assume, and the web thickness we can assume as per the rafter web thickness, and flange also we can assume as per the rafter, and the grade is 355. Click apply. Go to bolts. So we are going to define the bolt diameter and the grade and the spacing. So diameter is M20 and the grade is 8.8. It is unthreaded portion only, the shear is going to act. So there are 6 number of rows we are going to place, and again here that 150 we are going to have as a edge distance E. So in horizontal directions we are going to give the spacing as 150, sorry. Then here, as you have, we are the 6 number of rows, we need to type 5 number of spacing here, so we can have it as equal spacing of 170 by 170 by 170. So by applying this, you can also see there is no bolt clash with the member, but here there are some clash, so that we can adjust with that value H1. So the H1 we can type it as 100 mm, so that you can see here that there is no bolt is clash with the web or flange of the beams and the haunches. So now all the things are applied. We are missed this weld, so type the weld thickness as 8 as uniform, and go to the code parameters. So the code parameters, everything is okay. If you want, you can increase the real beam length. So 10 meter we are having 18 meter, right? Yeah, 9 meter, because we have taken the 8, but this won't impact the design. So click apply and click OK. And we already extracted the force value in Excel sheet for beams, so you can see here. So this values again we need to enter into the robot model for connection in the force value. So here we need to enter all the force value. So all the force values are entered as per the Excel value. So click here. So now you can see the usage factor is 0.5, which is less than the 1. So this connection is safe with all the bolts, base plate and the hunch. We are going to do the design of wall bracing and roof bracing connections. So for that we need to go to the connections part, and before that we need to check that structural model for wall connections. So in this structure view we need to go to that results and select the forces. So this we already done for our previous connections. So this table is showing the result value for the forces, member forces. So here we need to copy this model which we have selected, that bracing members, copy and paste into this table and press enter. You can able to find out only the selected members force values are listed here. Then we can copy and paste into our Excel sheet. So these are the value we need to enter. So 39.82 is our axial forces for the bracing member which we have selected. Then go to the design, steel connection design. So go to this last icon which is showing the gusset plate truss card node. Click this. So this will show you the picture like this. So for us, in our case, we are going to design the gusset plate which is to be connected the two number of bracings in opposite inclined directions. So for our case, this 3 and 5 is applicable. So we need to untick all the irrelevant pictures. So you can see the pictures here. So we can mention this as a wall bracing. Click this diagonal, and we need to mention the sizes. So this is equal angle 100, both are the same, and also the grade also 355. So our the position is like this only. So both are same, the longer. So this case is both the equal, and as it is a equal angle, both the longer and shorter span are same. So this is 45 degree and this is also 45 degree. We are going to place the inclined only. So this is a 150, this EC3 from offset from the CG of the plate. And next go to the diagonal connectors. So these diagonal connectors we need to provide the bold values. So here we can assign M16 bold for both things the same. Also the grade is 8.8, unthreaded portion, and we are going to apply the 2 number of bolts. So okay, and we can apply here, and you can see the picture also here in that. So remaining dimension are okay with us, and go to the plate, and the plate dimensions we need to define. Plate grade is 355 and the size we can consider 600 and 300 and whatever which is showing here. You can click apply, and now we need to provide the input value for this. So as there are two member is going to connect, we need to enter the same value Now enter the force value which we have developed in that Excel sheet, and it is 39.82. So the both value we can enter as 39.82. So and click calculations. So here also that utilization ratio is less than 1, so that we can able to say this connection is safe. And as it is less than 0.5, even if we want, we can able to do some optimization by reducing the bolt diameter or numbers or the cassette plate thickness. So such a way we can do it. And similar way we need to do for the roof bracing also. So for a roof bracing also we need to do the same procedures. It's like we need to select these 3 and 4 as per the picture, and the member size we need to change according to the actual member size we have provided in the structural model, and also the grade of the steel. And the diagonal we need to fill this as M16 and 8.8 grade of bolt, and the bolt spacing also we have mentioned here, similar like which we have done for the wall bracing. Also this we need to define the grade of plates. Click OK, and this member force we already extracted in the Excel sheet, so that value we can directly enter. It is 128.53. the same value we can apply here. Click calculations, so it will give you it is 0.94 is a utilization ratio which is less than the 1. So we can say this gusset plate connection also safe in all the aspects, like plate gusset plate thickness and bolts diameter, number of bolts. So this with this all the relevant connections for the warehouse building design is get completed. Look description for more related videos and subscribe to this channel for more updates. Thank you.